Okay, this is a neuron, and here you have the cell body, which the message comes in through the dendrites on the cell body, and the cell body interprets the message. And once the message is interpreted, it moves down the axon, which transmits the message, and it transmits it by using Schwann cells, which insulate the message, or insulate the axon in order to make the message move faster. And as the message moves down the axon, it jumps from each node of RON-VA. And these nodes of RON-VA increase the message speed, which allows for a faster transmission. And finally, once the message reaches the synaptic knobs of the axon terminal, the message is sent on to the next cell.
This is the resting potential in a neuron. Basically, there's more potassium outside of the cell than inside of the cell, which makes a more negative charge within the cell, and a positive charge outside.
This is called the electrochemical gradient, this difference of charge.
And then an impulse from outside of the neuron comes in, and more sodium comes into the cell, which opens the Na channels, and then the charge of the cell depolarizes, meaning the charges switch, and it's a positive charge within the cell because of the sodium. And
the message continues to move down the neuron, and once it reaches the end, neurotransmitters send the message on to the next cell. So this is how the electrochemical gradient is maintained by a sodium-potassium pump, and how an impulse is sent through a neuron.